The math section for Chapter 5 is measuring species diversity. One commonly used index is Shannon's index of diversity. To calculate this index, we must know the total number of species in a community, N, and for each species, the proportion of the individuals in the community that represent the species, P I. Once we have this information, we can calculate Shannon's index, H. By taking the product of each proportion, P1, and its natural logarithm, which is P and then summing these products as indicated by the summation symbol. This E is a summation symbol. This is the equation used. The minus sign makes the index a positive number. Higher values of H indicate a higher diversity. Imagine a community of 100 individuals that are evenly divided among 4 species, so that the proportions P1 of the species all equal 0.25. We can calculate Shannon's index as follows. H equals a negative 0.25 times in 0.25. This is what the equation looks like with a community of 100 individuals that are evenly divided among 4 species. Then this would be simplified to H equals a negative 0.35, and then you would do that 4 times, giving you a final answer of H equals 1.40. Now imagine another community of 100 individuals that also contains 4 species, but in which one species is represented by 94 individuals and the other 3 species are each represented by 2 individuals. We can also use Shannon's index to see how this differs. The equation would be H equals, and the first group would be 0.94 for the 94 individuals of one species, 0.94, and then the rest would be 0.02 times in 0.02. When you do this out, you get H equals negative 0.06 plus negative 0.08. Then you have that 3 more times. Giving you a final answer of H equals 0.30. Because this value of H is lower than the value we calculated for the first community, we can conclude that the second community has lower diversity. Finally, imagine a third community of individuals in which those individuals are distributed evenly among all the species, but there are only 2 species, not 4. We can use Shannon's index to calculate this. This shows 2 even species of both equal 50 because there are 100 individuals and they are distributed evenly. Once again, we do this out. H equals negative inside negative 0.35 2 times to get an answer of h equals 0.70. The value of h is lower than the value we calculated for the first community because this community has fewer species. Note that the total number of individuals does not affect Shannon's index of diversity. Only the number of species and the proportion of individuals within each species matter. You can find this explanation written out on page 124 in our textbook. Thank you.